Good evening, everyone. I'm Pratyush Kumar Das, a pre-final year student of IIT Kharagpur, enrolled in its BTech plus MTech dual degree program, having majors in electrical engineering. Today, I'm here to present the panel with all the insights and data analysis that I have carried out in this project, that is Uber supply demand gap. So, coming at the summary of the project, this project basically looks into the Uber request data to spot on the gap between the supply and the demand. And here we analyze the hourly patterns of the cancelled rides or unavailable or completed trips so that we can know when the users couldn't get a ride. And similarly, we also used simple chats and tables where our main goal was to know how to improve the services from a business point of view. These insights can also help the Uber plan better driver availability and also reduce missed trips, thus making the experience smoother for both the users and the cab drivers. So coming at the problem statement, we have that many a times in a day, the users do face a problem in which they're either not able to find any cabs or the trips get cancelled automatically. So this often leads to frustration among the users, and they often resort to other softwares or applications like Ola or Rapido, where they can opt for better rides at less prices and for better comfortability too, keeping along with convenience too. So we notice that these issues aren't random, but they seem to happen during some specific hours, as per our analysis, which we are going to discuss at the further at the later point. So it's clear that without analyzing such things, it would be difficult to fix what is hampering the progress of Uber in some localities. So coming at the business objective, our main goal is to understand the pattern of ride requests across different hours of the day and identify whether the demand is high or the supply is low. So by doing this, we aim to make that Uber can make some smart decisions like increasing driver availability during peak hours or improving the app algorithms, which is the main spot on thing that they have to do. Yeah, so this was the summary as well as the objective of this problem. And coming to our data analysis point of view, first of all, as a data analyst, we imported some libraries like Pandas, NumPy, Matplotlib, Seaborn, sklearn.impute, which is a library from where we imported this module called Simple Imputer just to fill the missing values, but we didn't require it at the later point. And also we have this percentage matplotlib inline so that we don't have to include a specific code that is pld.show to represent the plots. It can come as we run the cells. So first of all, we were given a dataset by Labmentix that was regarding the Uber request data, and we converted it to the data frame, which is a variable storing all the entries in it by calling this function pd.readcv. And this function df.head, this basically shows the first 5 entries in the given data. So for example, we have a user with the request ID of 619 whose pickup point was the airport, not city, and his or her status shows to be that the trip has been successfully completed, and these two represent the request timestamp and the drop timestamp. So mainly from our point of view, we are not going to consider drop timestamp or driver ID or request ID because they don't make sense for the data analysis point. Our main point of interest is this request timestamp, at what time or at what time slot of a particular day a user is requesting for a ride, and to know what is the type of the status, that is the output, uh, as we can say from email point of view. And most importantly, we have to consider the pickup point, whether it was city or airport, so that we can analyze the problem from a all from broader aspect from broader aspect. Yeah. So coming to this feature selection means minimizing the features so that we can work on our data in a comprehensive or better manner. So yeah, in the same data frame variable, we just drop the columns like request ID and driver ID, as well as the drop timestamp using this code. So yeah, after doing this, we just wrote df and run this cell, and it shows the pickup point status and request timestamp. I'm not running the code cells right now, but if I want to do, I can do right now too. Yeah, it shows the DF, all such rows around 6,745 entries, along with three columns, excluding those three columns which are not required. Okay. Further coming to the point, we have the info regarding the data frame about what is the data type of the things that we are storing in our entries, like the pickup point, status, and request timestamp. This stores the object class data having no null values, so we don't require simple imputer at this point of time. Yeah, so after doing this, we are going to use the describe function, which is mainly going to show the frequent category of the trip status or pickup point or request timestamp, but it is not required at this point of time. And this dot is null dot sum code would also show zero values. So we have zero missing values as we inferred earlier. Coming to the next most important part, we want to parse the date time, the request timestamp into a date time object so that we can extract the hour and the day and many such important aspects from it. So we created this particular code where it is known by a function clean date time column, where it basically we received the dataset in the form where some entries had the timestamp with hyphens in between them. We just replace them with slashes, or we can replace the rest of the slashes with hyphens, so that the parsing becomes easier. And we didn't have to do it in Excel. We did it through Python in the Jupyter notebook, also with the help of Anaconda library assistant. And after this, we created this request timestamp, which just made sure that the datetime object was created. After running this df cell, code cell, we have this. So basically, yeah, sorry, we do have this one where we have parsed the time alongside the date as the datetime object, and after that we created rest three columns where just we have the hours, the day, and the time slot. This time slot has been determined through bins. We created the bins in the multiples of 4, like 0, 4, 8, 12, 16, 20, and 24 through up to 23. So we have 0 to 23, where 0 to 4 represents midnight, and so on. And like that, we created the rest three columns, which represent I'm sorry, I have to run this code cell, and now I have to run this one where it shows the request hour, the day, and the time slot. So these three columns basically they give us more insight about what is the type of the day, what was the time slot corresponding to the particular entry which we are interested in. So like that, and this one's just a random, like, to run to see if it's parsing the right entries. Yeah, it's doing so up to 10 entries, and this sampling is also like that. So it was not necessary, but I did so. Yeah, after that, so we just basically pre-processed our data and cleaned the data. Alongside, we also extracted the most important features, which is known as feature extraction, for carrying further EDA, that is exploratory data analysis, so as to know the causes for such mismatches across the entries. So coming to the distribution, I used like Seaborn library or the Matplotlib library. So basically, I've used it the Seaborn library, where I have used the count plot feature so as to plot the distribution of different categories of the trips. So it's just a univariate analysis. It just shows the count of the total completed trips or total unavailable uh, trips, citing the fact that the cars were unavailable, and we also have another class where it is cancelled. So we have three possible categories, and this count plot just shows the frequencies. So we just see that there are more number of trips completed as compared to these two trips, which is not our point of interest. So this was just first foundational stage of the EDA. So coming to the main thing, our main aspect is to sort the request hours. Like if I'm having time ranging from 0 to 23, 24. So I did sort this request hours using this pd.to numeric function, as well as then sorted it using this sort values function. And later I created another count plot where it just, uh, wait a minute, it just shows the distribution of the requests made per hour of the day. Like how my requests are varying across the three categories per particular hour of the day. So this is just a count plot. We have three bars corresponding to each hour of the day. And coming to the main point, this chart is the first most important step in our analysis from the business point of view. And the insights we found were that a majority of trips were not possible during the evening and the night time, where we see that the blue color represents that no cars were available near the airport or maybe the city, and we have it as most frequent in these hours, that is 5 to around 9, or we can no, it's 5 to 9 p.m. So during the night time, it was mostly unavailable, and the trips were most often cancelled, which is represented by the green color in this timeline between 5 a.m. to 9 a.m. So yeah, this strongly indicates a demand supply gap between the users and the cab drivers. So surely focusing on these areas may be a positive can create a positive business impact. Uh, yeah, like that we also see the completed trips too. The completed trips are also higher in this timeline, which is just ironical to the fact that the trips were cancelled during this timeline. But these are corresponding to different users, so it's just an holistic insight. So coming to the main thing, we also plotted the pickup point versus the trip status, where we have two categories corresponding to the pickup point, that is the airport and the city, and we have the count. So if I would run this in cell, once again, I would be shown that we have a maximum number of trips completed in when the user selected the pickup point as city as compared to the airport. And the ironical fact is that maximum number of trips were also cancelled when the pickup point was city as compared to the airport. So once again, uh, and yeah, another fact that most number of trips were also not possible because of unavailability of cabs when the pickup point was airport as compared to the pickup point when it was city. So this chart was just chosen to give us a clear comparison of how trips differ between city and airport uh, pickup points. And yeah, it highlights that while both locations see a decent number of completed trips, the city has a higher rate of cancellation as compared to the airport, where the yeah. So these patterns also help us to understand that the Uber services are also falling short. And if left unaddressed, these frequent cancellations in the city and the lack of cars at the airport could lead to customer dissatisfaction. Yeah, it's just a normal thing. Yeah, on the positive side, these insights can guide Uber to improve the driver distribution and reduce the service gaps. So these are just our insights on what Uber can do so as to bridge this demand supply gap. And yeah, the main thing that we come across is this hourly trip requests breakdown, which I have done through this cross-tab function between these two specific columns of that particular data frame, which I showed using Matplotlib library. And after that, we are viewing this particular count plot, or we can say this particular frequency plot corresponding to these three different categories per in the respective hours. And it was particularly chosen because it tells a very clear and visual story about how the trips are distributed throughout the day. Yeah, we came across the thing previously, but this is a little more insightful than the previous uh, visualization charts. So one key insight is that there are two major peaks in demand, like early morning as well as in the evening too. But during these peak hours, especially in the evening, a huge number of trips didn't result in the successful trips simply because no cars were available. So that's a major red flag. And these insights can be uh, incredibly helpful from a business perspective. They highlight that if we provide more incentives to the driver, and if we can introduce, like, we can convince the executives of the Uber to take such steps like increasing the fare ride, keeping it minimalistic from users' point of view. That would be better. But if unresolved, this can lead to negative outcomes and also can result in declination of the trust, as well as this can lead to less revenues generated for the company too. So yeah, this was my insight, and after that, I have come to the thing where it is known as daily trip request breakdown, where we have different time slots of the day corresponding or showing different trip statuses, like this thing that we have shown here. So it's also showing, yeah, from it's the broader thing of the previous chart, but it's more concise, and to know the this can help us to do a better analysis. So this chart was also chosen because it can make us understand about the patterns, and it also doesn't just show that the people are asking for the rights, but also whether those rights were completed or cancelled or not available due to availability of the unavailability of the cabs. So again, I'm coming to that point, that is the evening and night time saw a maximum number of unsuccessful trips because of unavailability of cabs. So one reason that can point out to this might be heavy traffic congestion in the city airport route that can result in uh, declination of the requests from the cab drivers. Otherwise, another thing may be that the cab drivers would be canceling the trips more often so as to introduce surge pricing, which can lead to a better increased prices over a period of time, and the user has no choice if he is not able to resort to any other ride app, or so he has to, at the end of the day, he has to choose Uber, and that's the point where they have to face losses, and the cab drivers are profitable by these cheap tactics. So these are just my prediction possibilities which can be leading to such things. And also, it could be due to the technical glitches during the night time where it may be showing the unavailability of the cars. So it's just a prediction and nothing else. We also have that during the morning, many requests get cancelled. One might think this cancellation of the trips can point out to the interest demand because of the office hours at that time. So the users don't want to deviate from their jobs so as to go to a farther place like airport from the city. While many such demands are available in the city, they could be potentially, yeah, fulfilling those demands and then later resorting to that, but they don't want to waste the fuel prices, and also at end of the day they would be getting paid less. So from that, it's not profitable to them, and therefore there's more cancellation in the rides. So one thing the business can do to improve the availability and reduce cancellations, that could lead to higher customer satisfaction and more completed rides, can be like providing more incentives to the drivers. Yeah, we would be coming to this point later, but I was just telling about the possibilities corresponding to this deviations in the status of the strips across the different sorts of entries in the frame. So yeah, so now I'm coming to the most important part. Yeah, so this represents the number of requests which were cancelled as well as unavailable per the time di- across the different time slots. Yeah. So basically, we have that this evening and night time correspond to the most unavailable and cancelled trips. This could be another just a mathematical insight. It could be due to more and more unavailable trips that it is overshadowing the fact that the trips were cancelled. Sorry, I'm completely sorry. It would be the fact that less number of trips would be cancelled in this evening and night time slots as compared to the trips which are unsuccessful due to unavailability of the caps. So that's why we have a higher number around greater than 800. Yeah, greater than 800 entries where we have these requests being not fulfilled. So basically, this chart was chosen because it clearly shows when the service was falling short, specifically how many ride requests go unfulfilled during each part of the day. The highest gaps, as we said, was in evening and night, where hundreds of users don't get a ride because there are no cars available. So for the business, it's a clear signal that the demand is high, but the supply is not maintaining with the demand. So by putting more drivers or improving the availability during these hours, they could increase the number of completed trips and make better use of existing demand without spending extra on ads or promotions too. Coming to the main part, but if this issue is ignored, the users may stop relying on the service, especially when they need it most. So this chart helps us to pinpoint the fact that where we are losing out and where improvements will have the biggest impact. So yeah, this was all related to the bar plots, count plots, and whatever we did the bivariate analysis, and now we are coming to this pie chart where we have the percentage representation of the total amount of the trips that were not available or unsuccessful due to unavailability of the cars across different time slots. So this was just the code logic where we selected those entries whose particular column, that is the trip status corresponding to the unavailability of the cars, uh, were chosen, and to study the distribution of these trips, these unsuccessful trips which are due to the unavailability of the cabs across these time slots. So on a similar note, this bivariate analysis also represents the distribution of incomplete trips citing unavailability of the rides during the different slots of the day. We also see around 62 of the percent of total trips were during the evening and night time, suggesting that the cabs would be busy in fulfilling the local demands or citing heavy traffic congestion that we had come previously to in the previous stage of the video. So yeah, it would be due to the heavy traffic congestion in that city airport road during such time, or less prices being displayed for such trips that can compensate for the fuel prices over round trips, suggesting a negative supply demand relationship. Yeah, similarly, we also came across the cancelled trips distribution across different time slots where we have a point record near 77 of the cancelled trips pointing towards morning time. So yeah, we had also come across these points like the inrush demand due to the offices at such hours, or maybe cheap tactics by some drivers so as to kick in the surge price, which can prove to be profitable for such cab drivers, thus dictating a negative business path. And yeah, we also have created a heat map where we have this particular scalar that is 100 to 800, where it is showing that darker is the color, lesser is the number of the trips. Yeah, and lighter is the color. Yeah, it's vice versa. So we have the more number of trips pointing to unavailability of the cars being higher in this evening to night zone, and similarly, more number of trips are completed during the morning, and more number of trips are also cancelled during that slot. So just a ironical fact. But yeah, this is completely data analysis, and we are going to face such issues or such anomalies too. Yeah, so yeah, this heat map also chooses also represents all such things like we came across before. So this points to serious supply issue during the high demand hours. People are often traveling back from the work or going out in the evening, but driver availability tends to drop, likely due to fatigue, safety concerns, or lack of incentives. This mismatch leads to lost trips and lost revenue, and even worse, frustrated users who might stop using the app. So the chart also shows that early morning and morning of higher cancellations. Yeah, we also came across these points before. So our main motive is to boost both user satisfaction and trip completion. So for that, we once again came across this particular heat map where it shows the distribution of the trips corresponding to the two pickup points. Yeah. So this is the most important part and the final part of this EDA, where we have this heat map compares the trip outcome list and pickup points, and it tells an important story. The airport shows a higher number of unfulfilled requests, maybe due to no cars being available or the cancellations are quite low, which is uh, which is in contrast to that particular point that I mentioned before. So yeah, this suggests the key issue like the demand at the airport would be very high, but the supply isn't keeping up. Many travelers likely need rides upon arrival, but few drivers are available, possibly due to long wait times, restricted entry rules, or lower driver interest in airport pickups. Meanwhile, the city sees more cancellation, which could be from traffic congestion, short distance fares being rejected, or inefficient trip assignments. So, from a business standpoint, this chart shows a clear opportunity. Better planning around the airport pickups, such as holding zones for the drivers, higher incentives, or improved queue management. So addressing these gaps might help to fulfill more high value airport rides and reduce the missed revenues. So yeah, this was the end of our exploratory data analysis. All such stuffs that we had done come to a conclusion, and the solution to the business objective which will be presented before the conclusion, that is we can choose this five. I have mentioned these 5 points where we can increase the drivers availability during the peak hour. Like demand is the highest in the evening and the night, but supply often falls short. So we should offer time-based incentives or bonuses to encourage more drivers. Like suppose a driver is choosing a particular region at that airport, like any such terminals, we can represent them with some additional bonuses, which would be visible to their interface, but like it would be 2 times the price or 3 times the price at the same time, keeping in mind about the uh, economic uh, aspect of the user or customer too. So this can attract more drivers to this location through this particular incentivized method. And we can also improve airport pickup experience where airport requests are often unserved due to few available drivers. So we can set up holding zones, simplify the pickup flow, and offer higher payouts for that. Also, we can create smarter trip matching where you can use intelligence matching system. Suppose the driver is nearby to the user, we can match that particular driver to the user as compared to those who are outside a particular radius that is predefined. And we can prioritize high weight or high demand areas and also reduce assignment delays to improve the completion rates. And we can also have to focus on reducing the cancellations at the city locations. But the cancellation can stem from the fact about the short trips traffic or round trips or poor driver rider matching. So allowing the drivers to set trip preferences and provide more transparency about trip details before accepting would be a better solution. And yeah, like that. And last important thing is to collect the real-time feedback from the drivers and riders. So from where we can use this data to fine tune the policies, driver incentives, and app features, building trust and loyalty on both sides. Yeah, this was all the solution to this particular business objective. And coming to the main conclusion, this project provided a clear data-driven understanding of how the different requests are handled across different times of the day. and pickup points, highlighting the key issues in supply demand mismatch in around the city or the airport. By analyzing the patterns of cancellation, unavailability, and trip completions through various visualizations, we identify critical service gaps that lead to lost revenue and decline the user's trust. So our insights finally point towards the actionable strategies such as boosting driver supply through targeted incentives or improving airport pickup logistics, optimizing trip matching, and reducing cancellations through flexible driver preferences. By addressing these gaps with practical, user-focused solutions, the platform can significantly improve its trip fulfillment, enhance customer experience, and most importantly, drive sustainable business growth. So ultimately, this project serves as both a diagnostic as well as a roadmap to helping the company align its operations more closely with the real world demand. So this was all regarding this data analysis. I found it really interesting, and I also gained many such insights on how to deal with such data sets, how to clean the data set, which features to select, which features to avoid, and most importantly, which categories to consider for analyzing this data better so that we can make better conclusions or insights from this particular data analysis part. So yeah, that's all. And finally, I also would like to show my dashboard where it represents different such graphs or visualizations which I've done through the Excel. And yeah, this is my dashboard data, which is just like a representation in the Jupyter notebook that I had done. This represents the cancelled trips percentages across the different timelines, and this also represents a triangular wave plot where we have the cancelled trips versus the unavailability caps, specific trips or the completed trips. We have also this request status by the pickup point graph too. And finally, we have the spiral plot where it shows the concentric circles, and these particular timelines represent the times of a particular clock, and these times are not ordered, are not pinpointed like that in the clock, but yeah, it shows that most of the cars unavailability was during the evening or the night time, and most number of cancelled trips was around the morning time, as we can see from this blue projection that is projecting from the center. So yeah, that was all from this side. Thank you, and have a nice day.